Hello everyone. So welcome on back to factoring, but in this video we are going to show you how to factor by completing the square. So when we factor, of course, we are typically trying to factor a quadratic expression or trying to solve a quadratic equation. Quadratics, of course, come in the form of ax squared plus bx plus c. Now, in order to use this completing the square method, we need to make sure that first our a value is 1. There is a way to use completing the square where a is not equal to 1, but we're going to go ahead and for this particular video, focus on where a is 1. So, our quadratic expression looks like ax squared, because a is 1, plus bx plus c. Now, if this were an equation, it would probably most likely be equal to 0, but it could also be equal to another value as well. When we complete the square, what we need to do is we need to get rid of any singular numbers. In other words, anything that is just a constant, just a number, it needs to go to the other side of the equation. How we'll do that is whatever opposite operation is needed. So in this case, because I'm adding c, we're going to go ahead and we will subtract c from both sides. And then what we get after subtracting c on both sides is x squared plus bx is equal to a negative c. In this case anyways. Keep in mind that c, or the number on the other side, might be a positive. But this is what we want. We want to just see our x squared term and our x term on one side of the equation, and then the number is going to be on the other side. And then in order to complete the square, here's what we need to do. We need to take our value for b, and we are going to divide it by 2. And this will give us some number. Let's go ahead and just use the symbol for number. And then what we need to do is we need to take this number and we are going to multiply it by itself, or in other words, we are going to square it. And this value here is what gets added to both sides of the equation in order to complete our square. Now, what does that look like for our new equation? It will look like x squared plus bx. And I need to, like I said, add that number squared to both sides of the equation, right? We're working with the law of equality, which means that whatever I do to one side of the equation, I need to make sure that I do it to the other side as well. And then what happens here is that it creates kind of what you could consider to be a perfect square on the left side of the equation. What do I mean by that? Well, if you were to go ahead and take the magic x and factor the left side, what we end up with is x plus our number, and that whole expression is squared because we actually end up getting 2 of these. So this is why it's called completing the square, because at the end of the day, I want to end up with one single expression, and that expression gets squared. All right, this of course is going to be equal to negative c plus our number squared on this side over here. And then in order to finish this, you would need to go ahead and take the square root of both sides of the equation to cancel out the squaring here, and then continue solving for x. And that's how we complete the square. All right, now I know it looks a little bit funny with all these symbols. Let's go ahead and use an example to demonstrate how to do this. All right, so in example 1, they want us to factor and solve the following equation. Now, if you came across this equation here, maybe you went ahead and added 3 to both sides of the equation, And what we would end up with is x squared minus 4x. Let's write this down. X squared minus 4x plus 3 is equal to 0. Now, the dilemma that we run into here is that if I try to think about factors for positive 3 and try to see if two of those factors will add to give me a negative 4, or pairs of those factors add to give me a negative 4, we won't find any. So I could, of course, resort to the quadratic formula, or we could go ahead and complete the square. So let's go ahead and do exactly that. Now, when we complete the square, again, what we want is our x squared term and our bx term on one side of the equation, and then a number, any number, on the other side of the equation. And we actually already have that here. So because we already have this, we can actually begin the process of completing the square. We're going to go and we're going to take our b value, which is a negative 4 here. And I'm going to go ahead and divide negative 4 by 2, and this gives me a negative 2. From earlier, we said that we need to take this negative 2, and I need to square it. And this gives me a positive 4. This is the number I'm going to add to both sides of the equation. So if I rewrite the equation, I get x squared minus 4x. But now I'm going to add 4 at the very end of this expression. And this is going to be equal to negative 3, which is already there. But I also, again, need to add the 4 to the other side of the equation as well. This, of course, has to do with the fact that we need to make sure that we keep the equality of the equation by doing it to both sides. All right, and then from here, like I said before, if we wanted to, we could go ahead and use the magic X. Let me quickly do it just to show you that what we end up with is two factors that are exactly the same. So negative 4 is going to go down in the bottom because that's the number I add to, and the number we're trying to multiply to is this positive 4. Okay, this is technically our new C term. Now, two numbers that multiply to give us a positive 4, but add to give us a negative 4, that's going to be negative 2 and negative 2. So when I factor this out, or rewrite this equation in factored form, I get x minus 2 times x minus 2. Take a look at that. This is what I meant. We have two factors that are exactly the same. And this, of course, is going to be equal to negative 3, plus 4, which is a positive 1. But like I said earlier, because these two factors are exactly the same, I can rewrite them as x minus 2 squared. Because I'm just multiplying it by itself. And this is equal to 1. All right, so from here, I can go ahead and I can square root both sides. And the reason why I'm allowed to do this is because the outside operation is a squaring operation. So to cancel out the squaring operation, I need to square root both sides. That allows me to cancel out the operations. What I'm left with is just x minus 2, and this is going to be equal to a plus or minus 1. Again, because if I square positive 1, that gives me 1. But if I square a negative 1, that also gives me, or gets me back to a positive 1. Last but certainly not least, we are going to go ahead and add 2 to both sides of the equation. And we get that x is equal to 2 plus or minus 1. We can evaluate this, of course, because this really just means x is equal to 2 plus 1, or x is equal to 2 minus 1. So x is equal to 2 plus 1 means that x is equal to 3, or x is equal to 2 minus 1, and that right there is a positive 1. So that is our final answer for x squared minus 4x is equal to negative 3. All right, so go ahead and pause the video here and see if you can give a try on your own. All right, so go ahead and check over your answers. Again, you need to make sure that you first have your x squared term and your x term on one side and a number on the other side. Again, it's already in the correct form for you. So we take the value for b, divide it by 2, take that number, square it, and then you will need to add it to both sides of the equation. You can, of course, go ahead and factor this using the magic x, but if you remembered from our notes, all I need to do is I just need to take x and add whatever number I got here, and this whole thing gets squared. And then, of course, we're going to go and we're going to square root both sides to get rid of the squaring operation here. And then last but not least, finishing the solve for x, please remember that when you square root both sides, it's actually technically a plus or minus. So we should have two answers. X is equal to 9 and x is equal to negative 3. All right, so that's it for this video. Thank you very much for watching.